So in today's video, we're going over nucleophilic substitution. However, today we're talking about how you can convert a halogen alkane into an amine. So a halogen alkane is anything from group 7, any atom from group 7 bonded to an organic molecule. Whereas an amine is an organic molecule with the functional group NH2. So here are the conditions needed for this reaction to happen. We need ammonia and we need to heat it in ethanolic conditions. So as you can see here, let me just rub these out. We have a carbon-bromine bond. We know that the carbon-bromine bond is polar, with bromine being slightly delta negative and carbon being delta positive. Because of this, the bond can split heterolytically. When I say heterolytic fission, I mean both the electrons in the covalent bond can go to the bromine. So what this means is that we have a carbon that's positively charged. Now, what do we know about nucleophiles? They love positive charges. So, the electrons from the NH3, which has a lone pair, by the way, on the nitrogen, can attack the delta positive carbon. So what happens is that now we have the NH3 bonded to the carbon chain and a bromine or a bromide ion with a lone pair. So this mechanism actually has two steps. In this second step, we have a second ammonia molecule. And over here, you can see that the nitrogen has a positive charge. Why is this, you may ask? So initially, in NH3, nitrogen will be bonded to 3 other atoms, 3 hydrogens. But now, it's bonded to 3 hydrogens and 1 carbon. Because of its lack of a lone pair and these extra bonds, nitrogen now has a positive charge. But in this reaction, you can kind of imagine it in terms of nitrogen wanting to return to its initial state. So nitrogen doesn't want this positive charge. So what happens is that a hydrogen gives up its electrons and the NH bond, and then the lone pair on a second NH3 molecule is able to attack this hydrogen. So as we can see here, this hydrogen has bonded to NH3, so it will look something like this, with a positive charge on it. And then we still have the bromine that we kicked out the molecule initially. And then also, we have our lone pair back on our nitrogen, because both the electrons in this covalent bond went back to the nitrogen. So that's essentially it for this video. If you have any more questions or any other topics you'd like me to cover, please let me know. And yeah, thank you so much.